Welcome back to React Native Radio Podcast. Brought to you by Privacy. I'm just kidding. Privacy doesn't exist. Episode 279, Securing React Native Apps.
Hey, Mazen, you're from New York, right?
Yeah, I spent a good amount of time there.
Have you been to Jersey?
All the time. I mean, it's kind of like the gateway to the rest of the U.S. You have to drive through the Jersey Turnpike to get anywhere.
So does that mean you have gotten gas in New Jersey and had to sit in your car while someone pumped your gas for you?
Yep.
I live in Oregon, and we are notoriously, until like a week ago, the only other state in the country where you have to pump your own gas. And the law finally got turned down. So now we can all pump our own gas in Oregon. There's lots of mixed feelings about it, let me tell you.
Really? Interesting. Yeah. Whenever we come up for the retreat or Chain React, I go to the gas station right by the airport. And that one is self-serve. And that's just something I'm used to. Well, I say
Is it across the river in Washington?
No,
That's
it's right by PDX. Do I cross the river? No, I don't think I cross the river. It's weird. It's full service. I don't know. But, I mean, having someone pump your own gas is a little bit weird, I think. But I feel like in Europe, it's normal for that to be the case.
Do they have they have attendants that pump your gas in Europe?
I think so, yeah.
So the U.S. is actually the states where you pump your own gas is actually kind of the weird thing.
I think so. Yeah, for the rest of the world. It's also odd because New York, if you're in one of the 5 boroughs for New York City, you're likely to get a gas station that's like one of those older looking gas stations where an attendant does come and pump your gas. And I don't think it's considered a full serve, but it's just one of those things where the pumps are like the old school pumps where honestly, I would not know how to work them. And it's probably one of those that don't accept credit cards also. So it's like their way of making sure that you pay and just don't pump your gas and drive off.
So that's where the controversy comes in, because people are, so like half the people are happy because they're like, it's faster. I just want to like pump my own gas, get in, get out, not wait for anybody. Other people are like, I don't know how to work the pump. I've never been out of Oregon in my life. Yeah. Like, what am I even doing here? So there's been a lot of mixed feelings. I think it's a good thing overall. It always takes way longer to have to sit and wait for an attendant at a busy station when you could just like get started yourself and then leave. Yeah,
and usually in Jersey for most of my experience, it's on the New Jersey Turnpike, like parallel to I-95. Whenever we're on a road trip, and those stations are very busy. So I really do think if it wasn't for the attendants there and people would have to get out of the car and pump their gas and kind of get back in and continue, I do think it would take forever at those rest stops. So if you're from Jersey and you still enjoy sitting in your car while someone pumps your gas, that's interesting.
Can't come to Oregon and get the same privilege anymore. I'm sorry to say.
Yeah.
It's just Jersey. Anyway, probably noticed Jamin's not here. So I, Robin Hines, am your host for the day. I am the director of engineering here at Infinite Red. I am located west of Portland, Oregon, where I can now pump my own gas. And I live with my husband and my 2 kids. And I've specialized in React Native for the past 6 years. I'm joined by my applaudable co-host, Mazen. Mazen Chami lives in Durham, North Carolina with his wife and not so baby boy. I just saw some pictures of your son, who is definitely not a baby anymore. He's getting so big.
Nope. Toddler tantrums are in full effect.
I feel that. Mazen's a former pro soccer player and coach and is a senior React Native engineer here at Infinite Red as well. And of course, I have to mention that this episode is sponsored by Infinite Red. We're a premier React Native design and development agency located fully remote in the US and Canada. So if you're looking for React Native expertise for your next React Native project, hit us up at infinite.red/React Native. And of course, mention that you heard about us on the React Native Radio podcast. So let's get into our topic for today. This was a highly requested topic. Jamin had a thread on Twitter a while back asking for what people wanted to hear about. And this was one of the top things that people asked for. So our topic today is securing React Native apps. Security is very important, and it's often kind of an afterthought. So we're going to go through a lot of the different things that you can do to ensure that your React Native apps are secure. And a little bit of a disclaimer, a lot of this advice, you don't have to do all of these things in every case. How secure you make your app depends a lot on what the content of your app is and what the risk is if it's exposed or tampered with. Some apps are low risk, some apps are high risk. So, I mean, use your judgment in your specific case. You don't have to do all of these things, but these are the things that will make your app the most secure that it can be if that's important to you and your company. So keep that in mind.
I will also add to that disclaimer. The current project that I'm on technically implements all of this stuff, and it gets pretty burdensome because it's a lot of stuff to manage. You almost need a dedicated team that's just focusing on security, because I think the listeners, you'll hear all this stuff. I mean, we have a lot of points. I hope we can get through all of them because they're all tackling security from a different angle.
So yeah, keep that in mind. If you have a pretty lightweight, simple app that doesn't have a lot of sensitive information, don't feel like you have to do all of these things. But here they are if you do need them. Go ahead, Mazen, and start us off.
Yeah. So the first one actually stems from a Twitter thread that Jamin put together, but the kind of like the highlight is don't store sensitive API keys in your app code. So Jamin put together this Twitter thread, which we'll put in the show notes, but he pretty much downloaded an app from the App Store. I won't name it, and unless he does, I'll let the Twitter thread speak about that. But pretty much a native app. He downloaded it, used a open source tool to quote unquote unzip the IPA file, and then eventually kind of parse through the source code and get the keys. So don't put your keys in the app. Now, we do have a story internally of what happened with our Chain React app, and I hate to say it, but I was part of this process. But
no, to make it clear, this problem has since been fixed and mitigated. So there's not a security flaw in the Chain React app anymore.
Yes.
So we can tell this story.
And you can't hack the app, so don't try.
And you can't hack.
Well, it kind of stems from Webflow. So we used Webflow from our backend just so that the designers can make ongoing changes the day of the conference and have quick live updates.
Our website, the website is Webflow, and so the app consumes the data, the same data from Webflow that the website uses.
So we thought that Webflow gives you a key off the gate, and you would anticipate that key is a read-only key. But to get a read-only key, it's kind of like hidden. So flip your mentality. If you're going onto somewhere to get a key, you expect the easy key that's right in front of you to be the read key, and then the key behind the link that you then click into is the write key, right? But Webflow decides to flip it and reverse it. That was the song, but yeah. I don't know if anyone got that reference.
Flip it and reverse it.
So that's one thing, make sure your key is actually a read-only key if you're just going to use it blindly. If you're going to use it, just
if you don't need to be writing data, please don't use a write key if you don't have to.
Yeah. So this kind of leads into like what happened with the app. Well, actually, before I go into that, so if it's a read-only key, you can include it. Yeah, it doesn't really matter. It's open source. Doesn't really matter at the end of the day if anyone gets it. There are some non-sensitive data you could also put in. I have heard, and I think Jamin mentioned this too, that Google Maps keys are apparently not necessary. You don't need to secure them. You can kind of just put them in.
The Google Maps documentation specifically says you don't need to treat this key as a secret.
You know that random Google services dash something plist info plist file that they always tell you to drag and drop. Mm-hmm. That has your keys in it. So apparently that's not necessarily needs to be sensitive. It's not sensitive, so it doesn't matter. And then same with your metrics and crash reporting. You might want to secure it, but you don't necessarily have to. I don't know who. You'd have to be really, really messed up to hack someone's metrics and crash reporting, and then just send them crashes that your app is crashing.
There's very little incentive to like use that as an attack vector, and there's very little like risk.
Mm-hmm. Yeah.
I mean, yeah.
Yeah.
The worst that they can do is send crash reports to your crash reporting like service erroneously, and there's just not a lot of incentive for them to do that in the first place. And so we don't generally worry too much about things like analytic services and crash reporting services and things like that. You kind of have to evaluate the risk of what could an attacker potentially do if they got a hold of this key.
Yeah. And if you do put a key that's, right also, what's the worst that could happen? I mean, you could get your data leaked. You could, you're going to get a lot of breaches. And then at that point, you have to deal with your users and making sure their information after that is secure and taken care of. But yeah, if it's a read-only key and something seems to be off, you can easily revoke it and kind of start over from there. So it doesn't matter. But kind of like the solution behind that is just build an orchestration layer for your API keys and secrets. So what that means is have a login authentication layer where the backend handles all those keys for you. And they send over user-specific, session-specific tokens. Those tokens can be easily necessarily hacked because it restricts who has permissions to it. So it's maybe the token has it's coming from this specific device. So it restricts it where it's just that specific device that's doing that. So if you notice anything wrong on the back end, you can easily revoke that token and force a refresh token through authentication, all that stuff.
It only ever impacted the specific user that it was scoped to, and
Yes.
right.
Very limited scope.
You've limited the damage to just like one tiny little slice of
Precisely.
your application. So
Exactly.
that ultimately was the solution for the Webflow key issue that we ran into with Chain React, was that we needed to be able to write data, or we needed to be able to like interface with Webflow without exposing this key. And so we built basically a custom web layer, which we could request a like single use scoped token from the web service and then like our actual Webflow key was stored safely on the web server rather than in the application binary.
And this all stemmed from, we were looking at adding the AI chatbot, and we realized that we're not going to put our OpenAI and Claude keys in there. So we found this issue and then eventually kind of pushed everything onto the web. So we have a middle, you can think of it as like a man in the middle backend service that does all the calls and returns all our stuff for us there. So that's a good and easy solution. And if you have a backend team, this is probably not new news to them anyways.
Yeah, most backend teams will know how to do this and be familiar with the concept. And so you may be wondering about tools like React Native config or React Native.env, which are pretty popular tools for storing environment configurations. Like for maybe you have a dev environment and a staging environment and a production environment, and putting your keys in there. And then you have a .env file for each one of those environments that's ignored by source control, not checked in. That feels secure, but it's not. In reality, it's not. Do not put secret things into environment file, like .env files with React Native config or .env. They're not secure. They still end up in your application binary. Really, those tools are for like differentiating config between environments. So think API URLs that are different, app names, client IDs, URL schemes, things that vary per environment, and you need to be able to swap in and out very easily depending on where your app is being deployed to. Do not think about these as secure for secrets. That's definitely a mindset shift that I had to make. I think a lot of React Native developers don't realize that these tools are not intended to keep your data secret. They're intended to make it easy to switch environments. That's really the only. So if you do have secrets, use an orchestration layer, like funnel through your backend like we've talked about. But really think about react-native.env and react-native config as not secret, not secure. Along a similar vein, let's talk about storage of persistent data. So if you're getting, let's say you have a backend that gives you a token for your user, or maybe sensitive user information like
address, name.
Right. Identifying information, stuff that is sensitive. When you shut your app down and you persist data in order to be able to rehydrate it when the app comes back up, you have several options for where you put it. The default place that most apps put it is like async storage or MMKV. These are not secure storage. So those should only be used for data that's not sensitive, not secret.
Yeah, I think MMKV in their documentation also has like a tutorial on how to encrypt your data when you put it in MMKV. Technically, a hacker knows exactly how to reverse that and decrypt it and get whatever information you put in there. So it's not really secure. It just kind of stores it locally with behind a hash that can be reversed and eventually give you that data back.
So if you, for stuff that's sensitive or secret, you're going to want to use secure storage libraries like Expo Secure Storage or React Native Keychain, both of which I think use the same storage mechanism under the hood.
Correct.
On
they use
iOS,
the native like Keychain.
Right. On iOS, it's Keychain. Android, it's Shared Preferences and Android Key Store, I believe.
I believe Key Store. Yeah.
So those are encrypted, secure storages on your device. I believe we use Expo Secure Storage in Ignite. So that's where you should be storing your sensitive information. Or another thing to consider is not storing sensitive information at all. If you have, especially like with really sensitive stuff like health information, you always have the option to not persist it at all and fetch it from your API every time the app comes up. That's another option.
I know a lot of people will say, well, hold on, I want to have a good offline mode experience. If you have an app that needs to be secure, something like Robin mentioned, health related app, I really don't think you need an offline mode scenario, right? Because what will I be able to use to get use the app for, whether it's like communicating with my doctor and all that kind of stuff? I don't necessarily see from a user experience perspective where that could work, where you would need that. Especially from a HIPAA perspective, I'm not sure exactly how that would work out.
If you're building an app that deals with PHI or protected health information, really, you should make sure that your team is HIPAA trained and most HIPAA certifications will cover how to deal with health information. But definitely consider using secure storage or not persisting that data at all. So another thing to think about is one that I think a lot of people overlook, which is deep linking. Deep linking is not secure at all. And the reason for that is because there's no centralized method of registering URL schemes. So theoretically, someone could register your app's URL scheme, and then anytime someone tried to navigate to your URL scheme, that bad actor who registered your URL would receive whatever information was included in your deep link. So if there's URL parameters or anything included in the URL, a bad actor could just intercept that by registering your URL scheme. So do not include anything sensitive in your deep link. Your deep link should really be as complicated as maybe an ID for a particular record, maybe, I don't know, something that helps get to the right place, like maybe a date or other, but there should be no keys, there should be no secrets, nothing sensitive in a deep link. So yeah, be mindful of that.
Just get the user into the app, onto the screen or the product you want them to be on, and then let the app handle fetching and authenticating if needed before showing that screen.
Always assume that your link could be opened by any other app. just like, yeah, whatever you put in there can be seen by anybody. A more secure option for deep linking in iOS is to use universal links, which are HTTP or HTTPS. And then you have to register them with Apple.
I believe they go through a deeper process of validation from Apple so that it's not necessarily just as simple as like putting it in your scheme and releasing the app that way. You have to go through a step-by-step process and actually fill out some forms and stuff like that and then get validated, and then Apple will only link it to that one specific bundle ID.
Right. You basically go to a web address which is registered with Apple, and then Apple will send you to the correct app based on what is registered with Apple through the developer portal. So it's much more secure and official instead of going straight into a URL scheme. So yeah, use universal links on iOS for deep linking. And if you're not using universal links, or we're talking about Android, don't put anything sensitive in your deep links.
So then the next one is always use SSL encryption for APIs. I think this is a basic one that everyone knows about. Just use HTTPS for all your API requests. Straightforward. I don't think I need to go into that one a lot more.
TLDR SSL is just like a certificate that your website has that lets the browser know that everything is encrypted and no one can read what's going back and forth. So whenever you see HTTPS in a URL, it means everything's encrypted and secure. That's pretty much a given these days. You really don't see a lot of people using HTTP anymore. So yeah, that's pretty basic.
So the next one is actually a very interesting one, and I didn't learn about this one until current app that I was on. So implement SSL pinning to avoid man-in-the-middle attacks. So what are man-in-the-middle attacks? Think of it as like an open connection. They usually lure you with the word free at the beginning. Free airport Wi-Fi, free stadium Wi-Fi. If you're at the stadium trying to watch a game.
Don't connect to free Wi-Fi, please.
Don't. Now, what is SSL pinning? It's a measure that like strengthens the trust and integrity between your app and your API requests. So it involves associating a specific certificate or public key that you put on your app and the server, so they both know about this certificate, and it helps protect against potential attacks so that it ensures all is good. So if you were to think about it from like a visual perspective, you have a certificate, client certificate on your mobile device, and you have a server certificate that has a key. Once you send in an API request, it does some hashing and matching of the certificates and confirms that those certificates line up with each other before being sent over. You might be like, well, what if I just create my own certificate? Well, you need to know what the certificate is on the server side. So there's kind of like that disconnect. They both need to match up and line up with each other. The downside of this is, you're using a certificate. It's annoying. It's happening with our current client. There's a lot of like issues along the way and stuff like that. And if some issue were to happen with that certificate, you need to renew that certificate, you have to create a whole new build to kind of get that certificate out there. That's one that could be used to help secure your API requests. The next one, implementing code obfuscation to make your code harder to understand and reverse engineer.
So this is a protection at the level of the app itself. So this is assuming like somebody has gotten a hold of your binary, which is really easy to do, as Jamin proved in his Twitter thread where he hacked into a IPA live. Really easy to do. So this is someone that gets their hands on your application code.
If you've been listening to the podcast for a while, you'll remember the podcast episode RNR 239, Shrinking Your App with ProGuard with James Hamilton. That was more about, I believe that was something that we covered ProGuard in that one from the title. But the company that does ProGuard, their name is called GuardSquare. They have two paid services that are called IXGuard, which is for iOS, and then they have DexGuard, which is for Android. What it basically does is it has multiple layers of protection where they call it code hardening, where they kind of harden your code and make it really hard to reverse engineer your code to kind of get you to see the code. So if anyone were to get a hold of your binary, you have to jump through so many hoops to kind of get your code. So if you think about it, this layer with all the other layers they've implemented adds a lot of complication to it all. And then Hermes bytecode rather than the JS bundle. I think, enable Hermes. I think it's a simple flag, and that kind of gives you a lot of steps out of the box also. I know IXGuard and DexGuard are paid services, so that's kind of something that as an org and as an app, you'll kind of have to figure out if it's worth it to implement. And I believe this happens on runtime, so there's not a lot of...
It's literally called RASP, which is Runtime Application Self-Protection.
There you go. So that's some good protection right there.
Yeah.
Now, the next one is performing integrity checks to ensure your code has not been tampered with.
Right. So there's like multiple layers of protection, right? So we have code obfuscation, which makes it harder for people to tamper with your code. But then these are integrity checks to detect if someone has tampered with your code.
Mm-hmm. Yeah. And the first one, I think, is just figure out if your device has been jailbroken. This famous open source contributor named Gantman, who some of you may know as Gant Laborde, has a library called JailMonkey out there. So I think that's a good one to kind of see if your device is jailbroken.
Yeah, because you don't want jailbroken devices messing with your services, because they can
easily
jailbreaking removes a lot of the protections that keep things.
Yeah, and if you're trying to
secure.
use something like the secure storage to store in your keychain, when it's jailbroken, that's not as secure anymore. It's easier access to all that stuff.
Google also has their own kind of version of this called Google Play Integrity, which kind of does the same thing. It can be kind of a headache because Google Play Integrity tends to reject things like EAS internal distribution gets flagged by Google Play Integrity a lot. Things like that could be more difficult, but it can be worth it if you're looking for that extra layer of protection. So a couple things left here. Don't forget about dependencies. Dependencies can be an attack vector, and especially with React Native and its ecosystem, which is highly, highly dependent on open source, you do have to be mindful and aware of your dependencies and making sure that there's none that have active security issues. Dependabot is a really good tool to have installed. It runs on GitHub and will automatically open PRs to upgrade dependencies that have known vulnerabilities. There's also paid services like Snyk, I think is how you pronounce it. SNYK. We'll put a link to it in the show notes, but it's a paid service for managing open source dependencies and managing security around them. You can always also run yarn audit or npm audit to see what packages have known vulnerabilities. And another really cool tool that we didn't discover until recently is npm diff, which lets you see exactly what changed between two versions of a package, which can really help when deciding whether it's safe to upgrade or not. You can see exactly what changed without having to pour through change logs and release notes and stuff. So npm diff, npm audit, and dependabot for your dependencies.
Now, the last one that we have on here is for all you paranoid devs out there, for advanced security.
That's some advanced.
Yeah. So this is one that's actually very complex and kind of goes deeper. And this is again for your API. So there's a company out there called Shape Security. I believe they've been bought now by a company called F5. F5? Yeah, F5 if I'm not mistaken. The name's changing and all that soon, but I think if you Google that, you'll be able to get it. So they're kind of like a proxy in front of your API. They detect the signature of your API where it's coming from, and the request, and they detect malicious attackers. So think of it this way: you before you trigger your API call, you kind of go out to Shape. Shape comes back and puts together some sort of headers in your call. Once you make the call, Shape's going to go out and determine that call and see if it's a non-malicious attacker. And if it's not, it'll attach to the header as it's going to your API, the correct, like a validation tool that the backend can then also use to validate and confirm. And once all that checks out, you kind of get a good response back. Otherwise, I believe all it does is just kind of fails and heads over back to your API with a failure sort of report. So there's that. You can also implement that on your authentication layer. I think that's kind of like the easiest step to do it, where you can eventually just see if your authentication fails, thanks to Shape, something's off right there. So just a simple proxy in front of your API. And then
good to know about.
Yeah. Something I learned about recently too. And then the last one is JScrambler, multiple layers of client-side security.
I read about this tool. It's intense. This is like aggressive. It actually attacks the people that are trying to attack your code.
Yeah. It works in your defense. It's a self-defending, anti-tempering, anti-debugging, code obfuscation, code lock, all that's kind
right.
of
It could lock your code to only run on specific domains, operating systems, browsers, time frames. Really limiting how your code can be run to prevent bad actors. Self-defense tactics. So if it detects that someone's tampering or improperly running debuggers, it will destroy the attacker's environment, which is really, I thought that was really funny that it would actually attacks the attacker back. So if you're really paranoid or have really, really sensitive application code that really can't be leaked, there's some advanced security measures for you.
I mean, all that said, that's a lot of information there and a lot of different
That was
tools.
a lot of information.
Yeah. So I think
at the bare minimum, if you want to take anything away from this episode, don't put secrets in your application code. Secure your APIs.
React Native .env, React Native config are not for API keys.
Use React Native or Expo Secure Storage or React Native Keychain. Those are the basics.
Here's a question, Robin. Would you put your API keys in .env or config if you've implemented all this other stuff? So let's say you have Shape, you have DexGuard, you have all that implemented. Is it then okay to have your keys there?
I still wouldn't.
I agree.
Because having an API key just it allows you to pretend to be a legitimate, a good actor. So just protect your keys.
You're creating more work for yourself, because if that key gets exposed, even though you have all this stuff in there, you still have to kind of go in there and create new keys, create a new build, and ... That list keeps growing from there. So just don't.
Yeah, we'll harp on it till the end of time. Mm-hmm. Don't put your secrets in your application code. All right. That's all we've got for today. If you'd like to nerd out more about React Native, check out Jamin's YouTube channel, Jamin's Code Quests on YouTube. We'll put the link in the show notes. You can also join Infinite Red's Slack community at community.infinite.red, or our Twitter. I don't know if I could call it Twitter anymore. Our X community. rntwitter.infinite.red. You can find me on Twitter, on X. I can't believe I have to say that, but you can find me on X at Robin_Hines and Mazen at Mazen Chami, and React Native Radio at React Native RDIO. As always, thanks to our producer and editor, Todd Worth, our assistant editor and episode release coordinator, Jed Bartosky, our designer, Justin Husky, and our guest coordinator, Derek Greenberg. Thanks to our sponsor, Infinite Red. Check us out at infinite.red/React Native. And special thanks to all of you listening. Make sure you subscribe wherever you get your podcasts. I do have a mom joke.
Let's hear it.
So credit for this joke goes to Mr. Darren Wilson. Hi, Darren, if you're listening. I made a belt out of old wristwatches.
Oh, here we go.
It was a waste of time.
That's a good one, Darren.
All right. We'll see you all next time.
Care.